G'day everyone, hope you're well and thanks for tuning in. Yep, still going, still slowly putting it back together. I'm now just putting the two yolks in. So I might just show you at the back now how these things are connected up, and that might give you guys some thoughts for your own designs. Anyway, let me just show you that now while I've got it all apart. So basically, as I've painted it all up now, so I'm just feeding the two yoke shafts through on either side. So this is the pilot side here, and it's got more connections. I've actually got a push to torque on one side. I've got a trim up and down, and I've also got another push button as well, which is not being used at the moment, but that's what that's going to hook up to, and that's going to hook up to that Leo Bodner board there. So they'll all cook into that Leo Bodner board once it's all hooked up. And then on this side again, I've got a couple of effectively just push to talk buttons. One of them I'll configure, and the other one I'll just have on a standby for some reason. I don't know what I'll use that for the Copilot. But basically these are now going to go through, and they're going to go through the back of the bearing. And this is just a simple plumber block bearing, which suits quite well and provides that stability back to the other side, because on the other side I've got this is actually a 3D printed bushing here, but that's a nylon one. So I haven't got a nylon 3D printer, so I got that done. That was very early on actually. I got that one. I designed it, but I got it 3D printed, so it's very strong and serves the purpose really well for threading of the shaft through. So I didn't need to have two bearings. You could run with two bearings, I guess. And you could also think about mounting a bearing inside of your panel. If you've got a flush mounted bearing, that might also work, and sometimes that might have been a better idea, but there's a little bit of play in this, which I actually don't mind. So anyway, but yeah, you could also use a bearing there. So just around the front here, so really all I need to do first is I need to get the mechanical linkages on. So that's obviously got to go onto the shaft first. And mine was a very simple design, again, just my design. So fundamentally, once this is on, it's just a rocking motion back and forth with a cross arm in between. I'll show you that once I've got it hooked up. But basically, if you have a look inside there, you can see I've just got, obviously it goes over the shaft, and you've got that little cutout piece through there. And all that's for is for a pipe clamp. So basically that pipe clamp, once it's clamped up, will sit inside there, a little bit like that, and that won't move once that's tightened right up. And once that's tightened right up on that shaft, that is very hard to move, so which is really good and very useful. So that then locks it into position with that one, like that. And then at the back of that, I've just got a sandwich piece, which effectively has the reciprocal cutout on there, and then that just sandwiches over the top and looks a little bit like that. And then obviously that whole assembly sits on there like that. And then you've got that on both sides. And then there's the arm, which links up at the top. And then so obviously when I rotate, they both go together. And same, and obviously like that. So the trick with this though is obviously it's a little bit of trial and error to make sure that these things are vertical relative to your yoke position. If you can imagine your yoke handles relative to this as well, so there's a little bit of trial and error in that. I've got some markings as well also on here just to make sure that the arm is, I guess, perpendicular or that way, so it's all lined up in that direction as well. So that's important. So just put some markings on here at nominal 100mm increments, just so I can make sure that when I put that excuse my camera work again, but when I put this on, that I've got that lined up at a certain point, and it's all working well. And then I literally just set one in position and adjust the other one to suit. So a little bit of trial and error, but I'll cut away now and I'll cut back to when they're assembled. The linkage arm is pretty basic. Again, it was just, for me, it's just an MDF arm with a bolt through there, and obviously, as you would have seen before, that just hooks in to the top there like that, obviously hooks up and then just rotates back and forth. So fairly straightforward. Hope that's helped you. I'll show you in a moment once it's all hooked up. Okay, so I've got the two shafts just mounted. I haven't done the mechanical linkage yet. I'll show you that next, but I've got them just ready to hook those up. But I wanted to just show you how I've done pitch and roll. So obviously this is the pilot side here as I look at it from the back, co-pilot there, and obviously everything is mastered off of the pilot side, and effectively that co-pilot just acts as a slave, which is obviously whatever it's going to see via the mechanical link, which the pilot instigates, or the co-pilot. Obviously it'll see it, and then when going on pitch back and forth, because we've got a common plate that the bearings are mounted to, there's a common plate assembly through there. You can see that the whole slider assembly goes back and forth. And if I didn't mention it before, that's just on draw runners. So you can get them from any hardware store. And I've just mounted some draw runners there, yep, work quite well. So nothing fancy. It's not a precision slider mechanism. It certainly has its limitations, but for the purpose of my simulator, it's good. So for pitch and roll, there's different ways you can do it. Fundamentally, it all comes, for me anyway, it comes back to potentiometers. So I've got a potentiometer here for pitch and a potentiometer that I'll show you in a moment for roll. But let's just look at the pitch side of it for the moment. Now, different ways you can do it. And initially I had a rack and pinion. So basically had a straight pinion there, and then a rotary or a rack gear mechanism going up and down. But I didn't like that. It was sort of wasn't meshing the best. So I ended up just doing a simple arm connection. So there's the potentiometer mounted off to the side. Obviously that's got to be in a fixed position, and this needs to rotate relative to this going back and forth. All I've done here is I've 3D printed, I don't know if you can see that or not, but I've just 3D printed basically that there'll be an arm that'll connect into that and drop over. So here it is here. And basically what I've done is that just connects onto there. It's a fairly snug fit, obviously, because you don't want to have much play in it. And then I just literally drop that over that piece there that you can see. And now when we slide up and down, as you can see, that'll slide to full range of motion what I need, back and forth. So using the arm like that. And the potentiometer just then, so the potentiometer just then hooks directly into my Leo Bodner board that I've got here. So that'll just, when I hook that up, that'll just hook back into there. And this piece here was just a keeper plate. So to stop that arm from jumping off, I just put a little keeper plate that sits in there nice and snug. And then that just keeps that in there like that. So that's the pitch mechanism. You might be asking, what's that there? They're literally just some guides, just to stop this. If this common plate was to get a little bit out of alignment, it would start sort of getting a bit awkward to move. So I've just got some guides there. They don't actually, they've got a little bit of clearance on them, but that's what I've used those for, just some guides to keep that nice and true and tracking. Now in terms of roll, again, so if at the end of the shaft here on the pilot side, you can see what I've got in there. I don't know if you can see that or not, but that's effectively the profile shape for the potentiometer. So basically what I've again 3D printed up is a simple potentiometer on a bracket that sits like that, and that basically then just sits there, and that will push into the shaft like that, and then is mounted on. So when that rotates, it'll rotate the potentiometer. I'll show you that once it's all hooked up. There you have it, potentiometer now mounted in, and you can see just potentiometer there, just puts through the 3D printed point. That's been press fit fairly snug inside the yoke shaft there, and then just wide straight back to the Leo Bodner board. So one potentiometer there, second potentiometer for this roll, pitch, going back to another point there on the analog points on the Leo Bodner board, which is a BU0836A. You can use Arduinos, you don't necessarily need to use this. I just found this a bit more useful at the time. So anyway, so now let's put the mechanical linkage on. Okay, there we go, there's the mechanical linkage now in place. And as you can see, both just rotate like that. And if I can probably just get a look, try and get a view with both the yokes moving at the same time, there you go. and back and forth on the tray. So yeah, pretty straightforward and works a treat. All right, I'm done for the day. I'm a bit knackered, so I'm going to pack up and carry on tomorrow. I think I'm going to move on to the console tomorrow, so I'll show you some of that.